Hey 30-2s, welcome to your last lesson in this unit called sinusoidals. This one's all about applications. Well, thinking back to polynomials, the last lesson in polynomials was also all about applications. And what we saw in that unit was that sometimes we actually don't want to find, math's greatest question, what is x? Sometimes what we want to do is we want to relate the context back to the values in our equation. So that's our job here. We're going to see how, in a contextual question, how it relates to A, B, C, and D. So we won't be doing a regression here. We're just going to be thinking about the question. Now, thinking of these values, when we're talking about a context, we always want to be thinking back to the question. Okay, so I'll show you what I mean here. Out of all of the cool applications of a sine function, so say even the sound of my voice right now is a sine wave. For some reason in math teachers are boring, right? We know that's probably the case most of the time. I'll throw myself in that group. But for some reason, we talk about a Ferris wheel because we all ride Ferris wheels every day, right? So here we go. A Ferris wheel has a radius of 3 meters. The rider gets on at the lowest point, 1 meter above ground. Sam gets on at the bottom, and it takes 60 seconds to go from bottom to top. And it says, let's figure out the relationship between Sam going around, and we'll make a sine wave out of this. So first thing we'll do, always draw a pretty picture. Well, Sam gets on 1 meter above ground. It's a Ferris wheel. I'm never going to get on right at 0 or else we crash and burn. And that would be a pretty crappy ride. Okay, so there they are. They're at 1 meter above ground at time 0. Well, it says it takes Sam 60 seconds to get to the top of the wheel. Okay, well, where are they at 30 seconds? Well, the radius is 3 meters. So that's this distance right here. It's 3 meters. And that is now going to be right here. So at 4 meters, it takes them 30 seconds to get around. So 30 seconds, they're right there. 60 seconds, they're at the top of the wheel. Well, if the radius is 3, I'm going to go up, or Sam's going to go up another 3 meters, just like that. So at 60 seconds, they're at 7 meters. And now let's just repeat the pattern here. Well, our time intervals are in 30 seconds in our table, it looks like. So 30 seconds later, where are they? Well, they're on their down swoop. So they're coming down. So at 90 seconds, they're back at 4 meters. And at 120, well, they're going to be at the bottom. And at 150, they would be on their way back up. So here it is. Here is the graph of a person going around on a Ferris wheel. You see, it's a sine wave. This models a clock. We get a lot of clock questions about the hour hand and the minute hand going around. Okay, so now, like I said, in an application question, we really want to relate back the parts of the context, in this case, the Ferris wheel, to the equation. So that's our job right now. Let's figure this out. So the first thing we want to figure out here is the average height, the median value or the vertical shift. Okay, let's work through some questions here. The highest point on the curve, well, we saw that was 7 meters. And the lowest point on the curve was 1 meter. Question 2 says, what is the rider's average height above ground then? Well, average, I know how to find the average of something. I take my values. In this case, I'm going to take my highest value, and I'm going to take my lowest value. And if I want the average, I add them together, and I divide by 2. Well, that's 8 over 2. That's 4. That's the average height above ground for Sam. Number 3, what part of the Ferris wheel does the average height correspond to? Okay, let's go back up to our pretty picture. 4 meters. Well, do you notice here, I'm just going to extend this line over, 4 meters is going to go through the center of the wheel. So the average height is the center of the wheel. So in the equation, the median value corresponds to the d value. But in the context of the question, what I want you to say is that's the center of the wheel, or in the context of the question, I want you to say that's the average height of the rider as they go around. That's what I'm talking about. When we're in a contextual question, how does it relate to the context? Okay, let's take a look at amplitude here. We know we've got 2 ways to find the amplitude. Okay, my favorite way is simply, I'm just scrolling back up to the graph here. Friends, my favorite way is simply just to count on my fingers. From there to there, or from there to there. I can count. That's 3. So to me, that's the easiest way to find the amplitude. Amplitude's 3 meters. It's how much I vary. Okay, if you would like a formula though, what you do is you go max minus min divided by 2. Now, something that's really important here, you need absolute value bars here because amplitude is always positive. So it would look like this on that question. 7 minus 1 divided by 2, which is 6 over 2, which is 3. So either of these ways produce 3 meters. But what does the amplitude mean in the context of the question? Well, where did we see that 3 before? I'll scroll back up here. Where did we see that 3 before? It's the radius, right? It makes sense. How much am I going to vary from the center is going to be how large our radius is. So in this situation, the amplitude relates to the radius of the wheel. Again, that's the answer I'm looking for here. I don't want you to say the amplitude is 3. It is, but it's a Ferris wheel. I want you to say it's the radius of the Ferris wheel. Okay, let's keep going. Let's look at the period here. Let's go to pretty purple. The period is the time needed for a sine curve or data to repeat. So 2 methods to find this. Okay, well, we could find the distance between 2 maximums or 2 minimums. Or I'm actually even going to add in a third one here, or 2 median line, the time it takes to us to repeat on the median line. So I'll say median line repeats. Or what we learned in our previous lessons, or is on our formula sheet, our period is 2 pi divided by b. So number 2, looking at the curve, well, we know the period of this thing is 120 seconds because they're going to have to give us that in the information. So it's the time it takes to do 1 full revolution. So the period is the time it takes to do a revolution. Okay, so again, relating it to the context. If I was asked, like in number 3, to write the equation, we need the b value, not the p value. So to find that, we'd rearrange our equation. We'd say b is 2 pi divided by the period. So in this case, we'd say 2 pi divided by 120. Or we could say that's 1 pi over 60. That would be the b value in our equation. So in fact, if I wanted to write the equation right now, here's what I have. The amplitude is 3. The b value is pi over 60 x plus c, I don't know c yet, and the d value is the center of the wheel, or the average height above ground. It's 4. So what about the c value? Remember before in the other lessons I said the c value, I don't really care too much about it. The answer is simply just yes or no. I don't need you to find it unless you're doing a regression. So the c value, or the starting point in quotations, basically tells us if a curve has been moved left or right. and it meets these three conditions. Originally, it's on the median line on the y-axis going up. If any of those three isn't true, the graph has been shifted horizontally. So let's go look at our graph. So I'll scroll slowly back up here. Let's go look at our graph. Well, I'm going to change to hot pink. So I go to my median line and I say, where is this graph going up on my median line? Right there. And I say to myself, is it on the median line? Yes. Is it going up? Yes. Is it on the y-axis? Is that on the y-axis? No, sir. So this graph has actually been moved over to the right. So the answer to our question, has this graph been shifted left or right? The answer will be yes. This graph has been shifted. Okay, I don't need you to find that C value for me. We could find this C value because yes, it does have one. The only way I expect you to find that is by doing a regression. And if you do a regression, you must be in radian mode. So as you're going through your questions in your homework and you're relating these new contexts back, it won't always be a Ferris wheel. This was just one type of example. Sometimes it's average temperature over the course of the year or hours of daylight. What I want you to think, start here as always. This is your average. That's the first thing I find. Then I go here. The amplitude is how much I vary up or down. In this case, it was the radius. Then I go here. This helps me find the period. So this is from the period. It is not the period. Okay. And then the last one, which isn't that important, it's simply where do we start? Okay. And you do your little test. That's it, friends. I will see you in another unit.